Hello, everyone. Thank you for warm welcoming. I'm Hanna from Revolut. I work as a data scientist, particularly in a credit department and research and development team. I work on applying machine learning AI to solve financial tasks like risk estimation, personalization, income prediction, and so on. And today I want to talk with you about a different way of thinking, treating, and looking into our transactional data. Not just some data points, but more like a sequences we can learn from. And what is important, that we inspired by the techniques, embeddings from computer vision, from natural language processing, to use this technique, embeddings, to transactional data. That's why it's got two big steps. First of all, our transactional data is not just data points. And the second step is we switch from machine learning models to training encoder to build embeddings. Okay. Then here the numbers we are dealing, and there's the scale. 94 million customers over 41 countries, generating 1.5 billion transactions every month. These numbers are huge, they are big, but what is more important for us? Because each transaction is some financial decision, and we want to unlock the power and to understand this decision, not just summarize it, but to understand the pattern that because each customer lives a trial of this decision, top ups, subscriptions, and so on. And we want to understand this behavior and to unlock the information about stability, some changes, increasing, decreasing, and so on. And how we treat our transactional data in traditional way, current situation. We took our transactional data and we engineer features, yes, that even now we move from manual to automated way. We use such method called deep feature synthesis. It allows us to generate thousands of features automatically without human. And for example, we can build any features using different transformation aggregation functions. For example, we can calculate any formula like mean, summary, count of transaction. Add some category, like we want to know what is the maximum amount of transaction with gambling, for example. And it allows us, first of all, to build models on scale. It's very fast. Of course, we are able to extract much more information because creating 2,000 features, comparing what is human can create, is a big step forward. And now we have very powerful models with very high performance, but still, before we feed our model these features, we summarize, aggregate it into features. And that's why, like our training pipeline looks, first we have raw transactions, we use some techniques, we generate features. Here I talk only about transactional data, where we generate about more than 2,000 features when we do feature selection, because of course we need to select only significant, important features, and then we train the model. Mainly it's gradient boosting algorithm, random followers, light GBM, and so on. And we have quite impressive performance right now, but we understand this limitation. The model sees only aggregated features from raw transactional. And the question is, what is alternative? And let's think that instead of creating features and then build model based on these features, let's show the model the whole sequence of transactions. The model is able to learn from the order, the context, the time between. We want to know just not what people do, how they spend their money, but also when, and more about it. Maybe I can compare it with NLP. Yes, we all impressed by the performance from large language models. Here we can look at this picture as on the left side, we took text, we aggregated into some bullet points, and then we learn model on these bullet points. But on the right side, we allow the model, like we do in large language models, to read the whole text, the context, from start to the end. Here we do the same. We put the raw transaction sequence with all information in the model, and the model is able to learn more and to unlock these behavioral patterns from our sequence. And what exactly the model get as input? Here is example of one observations we put into the model. We took all the transactions from last time period, it could be 1, 2, 3 months, and each transactions in their historical order. Then, about each transaction, we have a set of attributes. We know about amount, we know about type, the currency, the state, maybe also some more information. Of course, here is only an example. But we are doing the step forward. We add some temporal aspects in the attributes. We calculate the time between client onboarding and this transaction, between transaction and the applying for credit product. That's why the model is able to learn from static attributes, from these temporal attributes, and of course from the whole sequence. It's able to understand these behavioral signals, some anomalies, trends, increase and decrease. And this a very first step forward, very big switch from feature engineering to representation learning. And then we want to make even better. We want to switch from model like machine learning model, gradient boosting, to embedding learning. We want to train, and we did it, an encoder. And this encoder, his job is to learn the input data and then to compress all this information into vector embedding, this powerful numerical representation of all information unlocked from the all transactions. And the idea of encoder itself to be able to generate this embedding vector numerical for any sequence of transactions for any user and create this embedding space. What is embedding space here? If you think about it like maybe some kind of segmentation, maybe clusters, if we train our encoder on default task, that's we expect that people with very similar risk level have very similar embeddings. Then I want to present you the training pipeline for our first use case. This first use case is about downstream task default risk. Estimation is just a binary classification model, default or not default. And first we have our transaction sequence, this raw information about transactions with all attributes and in historical order. Then the encoder itself, and the task is for encoder is to generate embeddings. Details about encoder itself. First of all, we have transactions, and the first step is transaction encoder. It should take each attribute, categorical, numerical, and embedded it. Then we have embeddings for all attributes, for all transactions, and then this stack of embeddings goes to a recurrent neural network. It also could be transformer, any architecture we want to select here. And then the final step when encoder generate us these final embeddings. Here it was a classification task. We just add one linear head. It's only two linear layers to predict probability of default. And when we compare our model on embeddings to the previous model, which was built on engineered features, we observed uplift in Gini about 6% in performance. Why Gini? For credit risk, it's not so important about accuracy, recall, precision. The main task is to order our clients from low risk to high risk. And then we select our risk appetite, how many risk we can allow. And then when we select this threshold, we accept clients where the level of risk is lower and reject if the probability of default is higher. Then here, if we are able to build a model with better performance, we are able to save the same level of risk by to accept more clients, to accept more credit products to be granted. Then also we compare the combination of prediction of these two models based on embeddings and based on feature engineers to our current model. And here we can observe the uplift even 10%. That's why this combination gives us even more powerful model and powerful prediction as the final prediction. Okay, and now the question, we want this encoder to be the game changer, and we believe in it. But how we can test it? Because here we train from end-to-end a neural network, and our idea and our goal is to check if this encoder is the game changer, first of all, and the second, if it could be reused as we do in computer vision, yes, that we have one powerful model which is able to generate embeddings, and then we can just do transfer learning for smaller data set, for smaller task, and to have very good performance. Of course, we did this experiment. First, we train an encoder. Here, exactly, it was gated recurrent unit on one segment of clients. Then we took totally new segment of clients. We freeze our encoder and we didn't train it. We just use it to generate embeddings for totally new segment of clients. And then even no neural network, just use these embeddings as numerical features for light GBL model. And again, we observe very good uplift in performance, very close to what it was originally, 4% in case when we compare two models, and 9% when we compare combined of two models versus our current model. And here we can prove that this encoder is a game changer. We can use an encoder without new training, just to generate embedding for another task and to maybe train some simple model on these numerical features, because embeddings is a vector of numbers. And how we work in Revolut in research and development, each time we have some success for the very first step, we need to put it on business before we will go forward. Yes, every small step should be implemented. That's why we are going to use this approach for different use cases. It could be marketing. We can use it in a fraud detection, personalization, maybe income prediction. And what is also important for us, both direction, use cases and some technical direction, because it's only our first step with very good progress, and next we can try different improvement. We can use more data. Just now we have only transactional data. We also have front event data. We can try much more powerful architecture like transformers. We think about unsupervised learning, because now the model is trained for downstream task as a default prediction. And here we are limited to the segment of clients with these credit products. But we have much more clients. We can use a bigger data set and to build this encoder on without any downstream task, only unsupervised learning. It will be much more powerful and more universal to use at any different task and use cases. What is also important here, such point is explainability, interpretability. Why we should think about it? Because banking, and particular credit domain, is a highly regulated. There is only a few examples with some documents, because we are regulated as a bank, we are regulated as a credit, also coming soon European AA Act, and so on. And it's not only about to build trust, yes, from our stakeholders, our people at business clients. We obligated to meet these requirements from regulatory, from legal perspective. And previously it was like, okay, we have our model, we have features, and they expect from us a list of important features we use in the model. But here we have neural network, we have embeddings. And now it's not something new to explain neural network. We can explain it, even I can, after my research, say that there is even libraries, very cool library, Captam. It was originally created to explain models built in PyTorch. Our model is built in PyTorch, but as a data scientist, I can explain this model to another data scientist, yes, and we can explain the prediction. But the challenge here is the step between. They expect from us some list of features, but we don't have features anymore. We have this the sequence of transactions. Even if someone will ask about the prediction, I'm able to explain it. But for the perspective of legal, we need every model to be very transparent, to explain it, to be very well documented, yes, and we need to prove that our model doesn't discriminate any customer. Yes, it's fair, there is no bias. And that's why it's a very hard work, and before we have some very good results, the work is done in research and development department, but then we want to put it on business. It's quite a challenge between us and, oh, no, yes, for us, but really now the main point that we are very excited that we are able, and we were able to unlock this switch from features to sequence learning, and to switch from machine learning models to embeddings. And that's why even my talk, I also want to maybe I was inspired, and I was inspire you, that when we talk about some kind of new models, transformers, architectures, we can try to look at our everyday's work and to understand how can we apply it, how we make our result of our work better, even without switching to text, images, and so on. That's why I hope it was also inspired for you, that we can look at our everyday work, everyday task from totally different angle. That's why if you have some feedback or you have some questions, please feel free to scan this code and leave it here.
I have 2 questions. Okay, we have 2 questions on the Discord. So do you calculate the risk score for default just from the user spending history? Do you take into account any external sources?
Okay, that if regarding the external sources, I can say that for default risk estimation, we use different sources of information. Yesterday was a presentation from my colleague, Mark, from Data Engineer. And yes, we use our internal data. We use data from Credit Score Bureau in every country. And that's why there is a list of different sources of information, and it's growing. We always working on it. And today it was just example how we can use transactional data. And as I mentioned, we are planning to add more data into encoder.
Okay. Question from Mandas. How do you get the reason for customers' credit score for the model? Meaning, if you want to explain based on which attributes the customer was marked as a default risk.
Okay, for our models where we have these features, we are able to explain, and it's our obligatory to explain the customer if he was rejected. Yes, that's why we are able to give the list of all attributes and to say why this decision is yes or no. Yeah, it's of course, but that's why here is the challenge that we need to switch from features to another way of explaining our decisions. And it's quite a challenge for us now.
Okay. Thank you so much. So is there any penalty on real-time inference?
Right now we are not expecting any problems with real-time inference. Everything is quite good from MLOps side.
Okay. Final question from the Discord. Did a regulator has approved the model?
Okay, I can say that it's not just that a regulator approved the model. I can say that I did maybe 10 speech inside our company for every level, first line of defense, second line of defense, risk manager, and so on. That's why, and the final step is our regulator. That at any moment we have get a list of questions from European Bank. Why explain each? That's why it's very. I even put it one slide additional to explain you this. Yeah, that's why before the model will be on production, there is a very long way for acceptance and proven.
Got it. Any questions from the audience? Here. Oh, go ahead.
Thank you very much. It was a very interesting talk. I'm just wondering how do you choose the length of the sequence of the transactions? I mean, how long of the events to check of the user?
Okay, it's even two dimension, the length of transaction and the number of attributes. Yes, and it was experiments. I did different interaction between number of attributes, the length of transactions, 1 to 3 months, and then the optimal point was selected. Yes, just you train your model and you look on the performance.
Got it. Okay. Any other questions from the audience? Oh, yes, here.
Or okay,
Yes,
now.
right now.
Is there a reason why you're using Gini instead of AUC, ROC AUC or any AUC metric?
Gini is a very common metric in finance, banking, insurance, just because we want to order our users from low risk to high risk. Yes, that is a very good metric for ranking it. Yes. Yes, mathematically.
Yeah. Any other questions from the audience? I have one in Discord and it will be the final one. Have you experimented with classifying transactions to avoid bias of unclear transactions? Or do you outsource services like Ondaro and apply category number to models of such cases?
It was quite.
Okay.
Yeah.
I know because I'm the visual learner as well. Because when I read, I understand. When I listen, it's like, what?
Okay, it's. I think there are questions. No, about avoiding bias. Yes, that's why it's one of our important part of all this model. Documentation and model review, because people from other departments, risk managers, they test our models on bias. Yes, they test our models and for any kind of stress scenario and so on. Yes, that's why it's one of these steps of model approval. And what about classification transactions? It's like we don't classify transactions, rather we build features from our transactions, or we now we switch from feature engineering to raw transaction sequences.
Great.